So here we have the rank correlation part. Here we have the rank correlation part. So now we already know about the correlation. So we do this correlation for two numerical variables. Okay, two numerical variables. How we gonna calculate the correlation coefficient? That is also we already know. This correlation coefficient is in between -1 to +1. Hari, if you can remember those ones, the -1 to +1. So that is there. So we can define and we can have these ones. We can have with a strong linear relationship, weak, strong positive linear relationship. Then this one is strong negative linear relationship. Likewise, there were like 6 categories. There were 6 categories which we normally divide this entire correlation coefficients into. According to the value what we received, we can have, according to the value we received, we can have this final explanation. So now for this one, we will be doing about the rank correlation. So what we have here in this rank correlation, background will be the coefficient of correlation. So the coefficient of correlation. Background coefficient of correlation measures the association between two quantitative variables. Or in quantitative variables, that means two numerical variables. But for the rank correlation means the question arises in identifying the association between qualitative variables. Now, if you can remember the variable stuffs, we have two different methods. One is quantitative, the other one is qualitative. So this rank correlation is for the qualitative variables, these qualitative variables with ranks. So these ones we normally searched for solutions. So for this, we have to know about the Spearman introducers. We have to know about the Spearman introducers. Now, how we gonna calculate this? How we gonna have this? How the following two variables get connected? That is, for example, let's assume we have the customer satisfaction here. So customer satisfaction now, what we have is, we can like put a, we can, so see now, from here to here, the customer satisfaction level goes up. For this side, strongly not satisfied. Here we starting from strongly not satisfied, but from here strongly not satisfied, but from here, it's strongly satisfied. From this level to this level, starting from this level to this level, what do we have? It's we strongly satisfied. The satisfaction level is increased. See this one. In this one, raving fan sells for you, advocate tells others about you, member feels belonging, customer bought again, shopper bought once, a prospect supplied details, and suspect which fits your market. So for all these ones, anyway, what it says, how the following two variables get connected. Our task is to connect these two variables, the customer satisfaction as well as this, we need to connect together. Now, our task is to connect these two variables together and build a rank correlation. So to do that, we have to apply the rank correlation. So how we apply this rank correlation? That is to test for a rank order relationship between two quantitative variables when concerned that one or both variables is ordinal. If you can remember the data types, we have ordinal data, then we have nominal data, then we have interval data, and also at last we have another one. interval data. The other one is ratio data. These are the all four data types what we discussed earlier. So ordinal and nominal both are for qualitative data. Both are for qualitative data. Qualitative means in Sinhala we would say ගුණාත්මක. Quality එකක් තමයි maintain කරන්නේ, that is non-numerical values. හැබැයි මේ දෙන්න how it differs for the ordinal data now we have an order. We have an order there. But for the nominal ones now, there's no any order. Just female, male category. But for example, we can have the gender for nominal data type. But for the ordinal data now, we can have the t-shirt size, small, XL, small, large. See, there's an order. And we have the two quantitative data types as well. That is interval data and ratio data. We already discussed those ones. But for here, for this, what do we have and what it's want, that is for the application of rank correlation. For this rank correlation, one or both variables should be ordinal. One or both variables should be ordinal, and also these ones not normally distributed. These ones not normally distributed when the sample size is small. When the sample size is really small, these ones are not normally distributed. That's what, if these three conditions are satisfied, then we can apply the what? We can apply the rank correlation if all these three conditions are satisfied. Is it clear up to this point?
Yes.
Okay. Then, aspect of using Pearson and Spearman correlation. There are two main different correlations. One is Spearman correlation. The other one is the Pearson correlation. So if we consider this correlation can be divided, or correlation can be calculated into two separate data sets. One is for the normal data, the other one is for the not normal data. First one is for the normal data, the other one is for the not normal data. If it's normal data, we have parametric tests and also we have the Pearson correlations. One method is we can apply the parametric tests. The other one is we can apply the Pearson correlations. For the not normal data, we have the non-parametric tests. As well as we have the Spearman correlation. So for this non-parametric test now, we are calculating Spearman correlation. For the parametric tests now, we can calculate the Pearson correlation. And also then for the normal data, for the correlation, now we have normal data and not normal data. So if it's normal data, now we can apply the parametric test for normal data sets. But for the not normal data sets, we have to apply the non-parametric tests. That's what we have. Okay, that is what in this sketch, in this diagram, that is what they explain. Now, we should know about the differences in between the normal data as well as not normal data. And also, what is the difference in between the parametric test as well as non-parametric test. And how the Pearson correlation and the Spearman correlation differs with respect to normal data and not normal data. Those are the very important things we should know. See, the aspect of using Pearson and Spearman correlation. Variable 1, variable 2, and the normality test we have to do. So for the Pearson one now, for the Pearson correlation coefficient now, either it's continuous or numeric, either both variables continuous or numeric, we can check the normality. But for the Spearman now, But for the Spearman, again the same thing, we can calculate or we can check for the normality. But here, to apply these ones, Spearman correlations, I said that one or both variables should be in ordered කියලා. In ordinal form කියලා. See, එහෙනම් one variable continuous or numeric and the second variable it can be ordinal now it is a Spearman. හැබැයි for both are ordinal now again it would be Spearman. හරිද? So for this last two, we can apply these correlation coefficients. Is it clear? So
Yeah.
to apply the Pearson num, both should be continuous and numeric. To apply the Pearson also we can apply in different methods. One method is both are ordinal. So for the other, another single Spearman method is one should be ordinal and the other one is both these ones are continuous or the numeric ones like this. That's what we have here. Is it clear?
Yeah.
Then important points in rank correlation application. So ranks, when it comes to ranks, we can rank it from either 1 to 5 or 1 to 10. We don't know. We can rank it whatever we have. So awful for fantastic. Likewise, we can do the rank correlation application like this. This is how we have. So that's what here we do the application part. Now they have given us some examples. What is it? For the first one is satisfaction of the product. See, satisfaction level, they have measured it, they have ranked it. Give me 1 minute. Oh, okay. Oh. So here what do we have for the examples? For the first category, they have the satisfaction of the product as a level. So level 1 to level 5. Maybe 1 is for the lower satisfaction level. 1 to 5 යනකොට the satisfaction level may be updated. So 5 represents the most satisfied level. And the credit ratings ගත්තහම and also for the satisfaction levels as well as the sales quantities as well. तर මේකට 200යි. ඒ කියන්නේ 200ක් මිලදී ගත්ත අය ඉන්නවා satisfaction level එක 0. 0 නෙමෙයි 1. 234ක් quantity එකක් ගත්තු පිරිසක් ඉන්නවා. They have marked that satisfaction level as 2 about this product. And 130ක් ඉන්නවා 130 people they have marked their satisfaction level ranked up as number 2. Again 2 නෙමෙයි මේක මම හිතන්නේ 3 වෙන්න ඕන. And here 4 and 100 persons who bought these ones are highly satisfied with these ones. So for the credit rating and the total investments, see here we have A plus, A plus, B minus, B, A plus. Likewise also, they have done the credit ratings. for all these credit ratings, then we have the total investments as well. We have the total investments bins as well, like this. Okay. Now, what do we have? Steps to be followed in the calculations. What are the steps we need to follow? What are the steps we need to follow during our calculations? That is, first we need to convert the observed values into ranks. Original values, original row data set, we need to convert into ranks. Then we need to find the differences between the ranks. We'll do a question. Then we need to find out the differences between the ranks. Then the third step, we have to square the differences. Why? Otherwise, plus or minus once we add all these ones, it will be cancelled and equals to 0. To avoid that, to get a numerical value, what we do? We just square the differences and have the magnitude or the value. And then we just add all these ones together. For the first one, as the first step, we have to convert the observed values into ranks as the first step. And then we have to find the differences between the ranks. We are finding the differences. Then for the third one, we need to square those differences and then we have to sum it up. See? So the formula to be applied, this is D. D is the differences. We denote it as D. D squared means that the squared differences. N is the number of variables, N is the number of items, or N is the number of variables or the items. So the rest of these ones are same, no? Squared terms. Now you know how to apply these ones. So here we have the sigma. Sigma means addition. Sigma represents the addition. So D squared values for a total addition that value should multiplied by 6 and divided by n times n squared minus 1. Here n represents the number of elements. Okay, number of ordered levels categories maybe. So then this is what we denote it as RS. That part is there. Oh, mandaka. දෙන්නට හානියක් නැහැ දෙන්න පැනලා. Okay, this is what we have for the formula to be applied. Is it clear the terms whatever we have here?
Yeah, okay.
Okay. So now for the interpretation, same as for the previous one, this correlation, though it's Pearson correlation or it's Spearman correlation, anyway, it is also in between -1 and +1. In a sample, it is denoted by RS and is by design constrained as follows. How? And its interpretation is similar to that of Pearson's. So for the correlation is an effect size, and so we can verbally describe the strength. We can verbally describe the strength of the correlation using the following guide for the absolute value of what? 0 to 19 now they have ranked it as very weak. 20 to 39 now as weak. 40 to 59 now, they have ranked it as, numbered it as moderate. 60 to 79 now, it is strong. 80 to 10 now, actually it should be then. Mitra point wise no. So 0.8 to 1 now, it is very strong. Likewise, they have categorized these levels same as for the previous one. Correlation coefficient earlier also we categorize these ones no, very weak, moderate, strong, and very strong. So this can be either positive or negative. We can have altogether 10 categories actually. Negative, very weak negative relationship, negative weak relationship, negative moderate relationship, a strong negative relationship, very strong negative relationship, and very weak positive relationship, weak positive relationship, moderate positive relationship, strong positive relationship, and very strong positive relationship. That's what we have. Now, they have given us the, now they shown us how do we rank. So for the for case one, first case, these are the stores. These are the distances. These are the relevance customers. Now, how we calculate this rank correlation? Then the second one is how do we rank for these ones, that is for the case 2 and case 3. They have given us these ones. Okay. Can you calculate these ones?
Okay.
So do you know how to calculate these ones? So anyway, මෙතන තියෙනවා distances with respect to the customers. So you can calculate the total number of customers like this here. And how we gonna different is, so first converting the observed values into ranks. එහෙනම් what you have to do, first these stores you need to calculate into these stores. First you need to calculate or convert into ranks. So they have put it as 1 2 3 4 5. No, again I'm also using these ones as 1 2 3 4 5. That is the first one. So once we have this one, so now we converted these ones into the values into the ranks. Find the differences between the ranks. Then they ask us to find the differences between the ranks. Square the differences and sum it up. Okay, so this is for the case 1. This is for the case 2, right? See, the values are different. Here we have 150, 250, මෙතන තියෙන්නේ 150. So then 300 for the third one, 300 for the fourth one, we have 100, 150. Okay, some values are different and some values are equal. So then what you can do? So how we gonna calculate these ones? They haven't shown us the method. So first we need to make it as an order. So what are we going to make it as order? Store distance customers. How do we rank it? How do we rank it with the customers? How do we rank it with the customers? We can rank it with respect to distance, or we can rank it with respect to customers as well. The number of customers, it would be actually the number of this one. So differences, we should have the 1, 2, 3, 4, 5. Now first we need to calculate the differences. So then what do we have here? I'm just thinking how to do this because they haven't given us any information to calculate this. How do we rank කියලා විතරයි they have asked. Did you do these ones during the lecture?
No, is the thing is when they did this lesson, I didn't go to the uni that week.
Okay. This one is for the correlation is effect. Correlation is an effect size, and so we can verbally describe the strength of correlation using the that is for the that is actually for the I mean the definition or the explanation for the correlation coefficients, no, that is there, and its interpretation is similar to that of Pearson's. Okay. So in a sample, it is denoted by RS and is by design constraints as followed. How do we rank and case one? Store distance, meters, customers. Distance with the meters and the customers is there. Okay, that part is there. Then, okay. Let me check how the rank correlation question comes. I'll just give you an example. Rank correlation. Rank correlation. Solved examples. See, මෙන්න මෙහෙම තමයි තියෙන්නේ. Okay, solved examples. Rank correlation, Spearman coefficient, solved examples.
Yes, I'll send an exercise we got from the
Yes. Send me, so
Okay,
that
I'll
I
send.
can have a look on it. Lesson 9. Okay, so here it says find whether there is a relationship between the grades for finance and the business management. Note the data set isn't normally distributed. Finance and the business management. Okay, so here what, right. This one it can be. So marks ne. So marks now, metana we can have it like we can have an order like 1, 2, 3, 4, 5, 6 likewise. And then what we can do, we can calculate the differences as well. How? 56 minus 66. 7, then may this one is this one is the variable 1. This one is the variable 2. Okay. So then what we have to do here 56, 75, 45, 71, 65. Likewise here we have the values. And the respective business management marks will be these ones. So now what we can do, we can first calculate the differences. To have the differences, I can like get the difference of these ones. 56 minus 66, that is minus 10, 75 minus 70, that is 5, and 45 minus 40, that is 5. Likewise, we can have these values. ඊට පස්සේ hello, okay. Eh? So this one we can calculate because we can have the differences in එහෙම තමයි අරකෙත් කරනවා ඇත්තේ. We can have the differences in between these values and the next term would be we have to calculate the squared of these values. එතකොට මෙතන එන්නේ 100 25 25 likewise we can calculate the what we call the differences and then what we can do we can apply this we can apply the previous what we call the අර equation එකක් තිබ්බේ what they have given us. So we can use that equation and calculate the rank correlation value. See that this one. මෙන්න මේකට apply කරන්න තියෙන්නේ. So the rank correlation, rank Spearman correlation would be this. Is it clear?
Yeah.
Okay. Can you, shall we do the exercise quickly?
Okay.
Okay. Let me share my screen with the. So here also that's what they have given. So this is the variable 1, this is the variable 2.
Okay.
That's how it is. Variable 1 and variable 2, we should have two variables. So the variable 1 with the distances, variable 2 with the customers. Okay, so where is that exercise? Exercise PDF, this one. Okay, just do the exercise, both the questions. I'll only okay, these questions are very easy. Okay, no problem. Okay, do it quickly.
Okay.
C squared minus 10, 25, 25, 121, 9, 6 times addition of these values, 10 times 10 squared minus 1, that is this one. So 0.557. Then you can comment on this. So if the value is 0.557, that means it should be moderate positive, right? As I can remember, it should be moderate positive. Wait. 0.55, no, 0.55 means that is lies in between this category. So that means moderate positive. These two ones. For the next one now, it is 6 times this one. 0.9, 0.977 means that is very strong. So you have to finally you have to say you have to provide that conclusion as well. That is there. Okay, that part is done. Then okay, then if this one is done, we can move to the next unit. So for the so now this chapter is okay, right?
Yeah, miss.
Okay, shall I? Okay, I'll then move to the 10th one. For the 10th one, we have, okay, that is for the regression analysis. Okay. Ayyo, very small chapter. Okay, so for this one is for the regression analysis. When it comes to regression analysis, we are calculating and we are talking about the simple regression. So before moving to the calculation part, anyway, we should know what is regression and how we gonna calculate the regression here. So that is regression analysis. So for the simple regression analysis. Now, when it comes to regression analysis, okay, we'll discuss what is regression analysis. So can variables can influence others? They are asking a question whether can variables can influence others. So one would be correlation, the other one would be causation. We discussed these two, we received these, we heard about these ones in the previous, I think, 8th chapter as well. So here, what will happen? For this, can variables can influence others? Yes, they can influence others in two different ways. One is correlation, the other one is causation. For the correlation, we learned that it is the relationship, or else we can say that it is the pattern between the values of two variables. Causation means one event causes another event to occur. It is a one event causes another event to occur. One event causes another event to occur. So, but for the correlation now, those two events are work independently. There's no connection between these two events. There's no any condition to happen it again. There's no any condition to happen one single event after the other one killer. There's no any conditions like that. So here in correlation, it's just a relationship or pattern between the values of two variables. But for the causation, if we calculate this causation, what will happen? It is for one event causes another event to occur. එකක් වෙන්න අනිවාර්යෙන් අනිත් එක වෙන්නම ඕනේ. Now, for causation, to calculate this causation as a coefficient, one event causes another event to occur, we can calculate the regression. In causation, where regression comes in causation. Causation is the place where regression comes to the topic. Regression is one tool used to identify the causation. Regression is a one tool used to identify the causation. That's what it is. Now what do we have? Regression is presenting the linear relationship between, now they are explaining what is regression. Here now, what is regression? That is, it is representing the linear relationship. Okay, when we draw these ones, we should be able to fit a line for all these entire data points. From that only we can say that these two variables have a linear relationship, or else we can say it with by calculating the correlation coefficient as well. So anyway, for the regression is present in the linear relationship between two variables by using a mathematical equation or model. By using a mathematical equation or a model. So for the regression shows how the variables are connected to each other. Regression shows how the variables are connected to each other. Regression shows how the variables are connected to each other. Is it clear up to this point?
Yeah.
Now, use of regression analysis. Why we use this regression analysis? What are the benefits we can have with the regression analysis? First one, known value of the independent variable. We can have a known value of the independent variable. See, independent variable, there's no any association. I mean, there's no any dependency in between those two variables. That is the first part. Then we can do the regression analysis for those two variables. Once we complete with this regression analysis, we can value estimations. We can value estimations for the unknown dependent variables. We can value estimations for the unknown dependent variables. So first one, how we use? First one, we have to calculate the known value of the independent variable. Then we have to do the regression analysis. And at last, we should value all these estimations for the unknown dependent variable. Unknown dependent variable. This is the entire step. So now we are moving to the regression models. Now we are moving to the regression model. First one is the simple linear regression model. Anyway, if you have done, okay, anyway, you have done all levels as well, no? So can you remember if it's a line now, the equation of the line goes as y is equals to mx plus c.
Yeah.
So m is the gradient, c is the constant. So in this simple linear regression model, the model gives us the same format of an equation. That is y is equals to a plus bx. Same format, no? A plus bx. Here, x is the independent variable. X is the independent variable, whatever we are changing. Okay. Whatever we are changing, or else we can say all the input values as x. So the dependent variable will be y. According to the x values we change, we are calculating the y output value. So x is the independent variable, y is the dependent variable. Is it clear, these two variables?
Yes.
So now for the linear relationship presented with a straight line, that's why this formula, model formula, looks as an equation of a line. අරක වගේම තමයි y is equals to mx plus c type එකේ equation එකක්ම තමයි here also we have received. Y is equals to a plus bx. So X is the all input values, Y is the respective output values for the, again, Y is the output values for these respective X values. X is the independent value, Y is the dependent value. A is what we call the intercept, B is what we call the gradient, the same thing, or else in here in statistics, we give them as the slope. In maths also, we use these words, slope and the intercept. These two are the coefficients, whatever we have in this simple linear regression model. Simple linear regression model. Now, actual activation of the regression analysis. What will happen? Though we calculate like this, you can see now for the previous example, see, now this is a scatter plot. This is a scatter plot. They have drawn all the points here, and they have drawn a fitted line as well here. Fitted line as well. See, this is the fitted line. So if I take this single point, now this is not in the line, no. We can calculate a small distance, small difference in between these 2 points. So we call that difference as an error. The may point it's not lie in this fitted line. Line that error would be 0. The direct distance should be 0. Habai for the alien points, you can understand singular little bit, right?
Yeah, Miss, I can understand.
Oh, okay. So මෙන්න මේ වගේ alien තියන points වලට we can calculate a small error because these points are not in this line. Not on this line. Line එක උඩ නැහැ ඒ points. If those ones also in this line itself, එහෙනම් the error would be 0. මොකද ඒකෙමනේ තියෙන fitted line එකේමනේ. But the rest of the මෙන්න මේ එළියෙන් තියෙන outside points, we can calculate an error. So now here, see, the actual activation of the regression analysis comes in that way. How the sales of the business determined, that is, there are number of influential factors. There are number of influential factors in the market which determine the existence of one factor. There are number of influential factors. ගොඩක් තියෙනවා. We have many influential factors in the market which determine the existence of one factor. එක factor එකකට influence කරන බලපෑම් ඇති කරන many factors there might be. Therefore, the value of one known variable, cannot determine with only one variable. හිතන්නකෝ, for example, we are measuring the growth of a tree or something. The growth of a tree or something, there we have to consider the temperature, sunlight, and what else? Soil leke මොනහරි තියෙන features තියෙනවා නම් ඒවා. Likewise, there are so many factors which we have to calculate, right? ඒ කියන්නේ when it comes to growth of a plant, only water level විතරක් නෙමෙයිනේ its effect for that. If we consider the water level as X and growth, the height of that plant Y, there might be several factors we need to calculate. තව factors තියෙනවා. අරක විතරක්ම නෙමෙයි මේ consideration එකට ඕන වෙන්නේ. So because of that, that's why they are saying number of influential factors in the market which determine the existing of one factor. Therefore, the value of one known variable cannot determine with only one variable. එකකින් කරන්න බෑ. And these other relationships are termed as errors. So these other relationships, මේ තියෙන අනිත් ඒවා ඔක්කොම, we calculate a common value called error and define it as the error term. Other relationships are termed as errors. E is the part which not described by the equation. අනේ equation එකේ කියවෙන්නේ නැති part එක තමයි we define it as the can we described can that part is not described by the equation, it's a hidden part. Hidden error එකක් තමයි ඔය තියෙන්නේ. Is it clear up to this point what I'm saying?
Yeah.
Okay. Then fit in the straight line. Now our target is we know how to calculate or how to find the how to draw the scatter plot. Once we draw the scatter plot, we can identify after calculating the correlation coefficients, we can calculate and we can have it whether, give me 1 minute. Give me 1 minute.
Okay.
Okay, so okay, now for this fitting the straight line for the relationship if for the straight line for the relationship of two variables can be drawn and determined by various methods such as what are those various methods? එකක් තමයි freehand method. The second one is a line using two middle points. A line using two middle points. Then the third one is a line using first and last points. A line using first and last points. The fourth one is least square methods. These are the four what we call the straight lines for the relationship of two variables can be drawn and determined by the various methods. These are the four methods. First one is the freehand method. Second one is a line using two middle points. Then the third one is a line using first and last points. The fourth one is the least square method. ඔය ටික තමයි how we calculate a fitting the straight line options. So then freehand method and its drawbacks. Freehand method and its drawbacks. So by looking at the plots of the scatter plot, freely drawing the line to connect the plots. May freehand method එකේදී නම් freehand නේ, we have to like drag and draw the line in our freehand by looking at the plots. Plot එක දිහා බලලා by looking at the plots of the scatter plot, freely drawing the line to connect the plots. There's no any mathematical calculations, no proper calculations in this criteria or in this method. So that's the major drawback actually, as there is no proper calculation to determine the straight line. The interpretation of the line can be misleading the decision making. So the line construction is subjective. That is the main drawback of this. So the least square method, when it comes to least square method, the deviations shows the errors of the model. The deviations shows the errors of the model. What are those errors? First one is, therefore, to get the best fit line, the errors should be minimized. E, the value E. Once we calculate all these errors, we should be able to, though these errors are there, we should be able to minimize all these errors. We should be able to minimize all these errors as there are positive and negative deviations. The errors can be set off. And will not present the actual errors. It will not present the actual errors because of this positive and negative values. That is the least square method. For this least square method, actually, the calculations are there. So in least square methods, the deviations shows the errors of the model. And therefore, to get the best fit line, the errors should be minimized. As there are positive and negative deviations, the errors can be set off and will not represent the actual errors there. It won't represent the actual errors. So then, to avoid the cancellations of positive and negative errors, අපි mean squared error එක calculate කරද්දිත් mean squared එක නෙමෙයි නිකන් error එක mean absolute error එකේ නම් positive values විතරයිනේ අපි ගත්තේ. එතනදී අපි අර නිකන් ඔය මේ square කරන්න නැතුව plus or minus එක calculate කරද්දි these ones got cancelled නේ. එහෙනම් to avoid that cancellation of positive and negative errors or the deviations, we have to square the deviations and it can be considered for the further calculations. Fitting the best line can be done by taking the least squares of the errors. Fitting the best line can be done by taking the least squares of the errors, which is called as least square method. ඒකට තමයි අපි කියන්නේ least square method එක කියලා. Therefore, it is accepted that the least square method is LSM. We called it as LSM as the short name LSM. So is generating the best fit line. So then with the error, we can rewrite the linear regression equation as y is equals to b naught plus b1x plus epsilon. Epsilon is the error. This is the same thing what we had earlier, that is y is equals to a plus bx plus e. That is the same thing. The same thing we have renamed with b naught and b plus, b naught and b plus, b naught and b1. Is it clear what I'm saying?
Yes.
Okay. So then once we have these values, okay, see the B naught is the intercept. We can read that value from the graph itself. B naught is the intercept and B1 is the slope. B1 is the slope and B naught is the intercept. B naught is the intercept and B1 is the slope. B naught is the intercept, B1 is the slope. That means actually the gradient of that. So now how the application of the formula it works, apply these simultaneous equations and derives values for beta naught and beta 1. That is sigma yi is equals to n beta naught plus beta 1 sigma xi. This is for apply these simultaneous equations and derives values for beta naught and beta 1. What we can do, we can calculate each and every, again, we can calculate the each and every xn. We can substitute with the graph x values and y values and find out the beta naught and b1 values. Beta naught and b1 values, as well as we can calculate the xi and yi's as well. Make a mehema kiwwata it won't clear for you. We'll do some examples. Then beta naught hoena, okay. කොහොමද මම මේක කියලා දෙන්නේ? Okay. So earlier, we had this equation. This is only for a single point. This is only for a single point. Let's assume we have 5 points. We have a graph with 5 data points. For all these 5 data points, if we are going to calculate this errors, least squared methods very best fit line, how we gonna calculate? What do you think? If we have 5 points, 5 points යන්න තමයි මේ ලියලා තියෙන්නේ. Sigma yi means our first point to fifth point, we have to add all the y values. ඊට පස්සේ මෙතන තියෙනවා first point to fifth point, we have to add all the x values. ඊට පස්සේ a value එක respective beta 1 ගෙන් multiply කරනවා and n is equals to 5 now, 5 times beta naught. With that formula, we can have this. This is applied for the all data points, whatever we have, all data points, whatever we have in this scatter plot. If we multiply the whole equation with xi, if we multiply the complete equation with xi, then what do we have? Sigma xi yi is equals to beta naught sigma xi plus beta 1 sigma xi squared. That's one. We received it with the multiplication of xi. So for these two, once we have these two equations, we can calculate the, once we have these two equations, we can calculate, we can simplify these two, simultaneously solve these two equations and find out the values for beta naught and beta 1. how we get this beta naught and beta 1? Beta 1 is Sxy divided by Sxx. Sxy divided by Sxx, that is Xxy now sigma xi minus මෙතින්නේ x part එක. xi minus x bar. Y part එක නම් yi minus y bar. මෙතන x means xi minus x bar. Again, we have to multiply it with xi minus x bar. හරිද? බලන්න term එක හැදෙන විදිහ. xi minus x bar represent the x part. Y part is yi minus y bar. Then again xi minus x bar should multiply it by xi minus x bar. xi minus x bar. xi minus x bar into times xi minus x bar means that is xi minus x bar squared. Harida, is it clear how we calculate it? The
Okay.
beta 1 value.
Okay.
Okay, so once we simplified it further, we will get beta 1 value. Mukadara method තියෙන middle terms got cancelled and it will summarize for Doctor. Give me 1 minute. Yes, doctor. Yes, doctor. Oh. Now it's 2, right? Shall I come? Mama දැන් නම් ඉන්නේ ගෙදර ඇත්තටම. 3 වගේ වෙනකොට is come නැද්ද? Huh. Okay, sure. All right, Hari. Huh. Okay, sure. Will do. Hari, okay. So then what do we have? Sigma xi yi minus n times x bar y bar xy bar completely should divided by sigma xi squared minus n x bar squared. That is making මේ equation එක simplify කරාම තමයි we will be having that I xi yi xi minus y bar x bar yi x bar y bar plus x bar y bar. Correct. If we simplified this first equation, then at the end you will receive the same equation for B1, that is sigma xi yi minus nxy bar divided by xi squared minus nx bar bar. I think for these equations now you will have these equations in your papers, right?
Yeah.
Anyway, you have to recall.
Now means we don't know what will happen because of the syllabus changes.
Right, okay. So anyway, for the alternative approach, now this one it's easy. So this one also easy. Sigma is there, that is for all the what we call, anyway we have to add these xi yi values. So sigma xi yi should minus n x bar y bar divided by xi squared summation minus n times x bar squared. Make poda ehaata mehaata baluwa නම් you will be able to recall this as well. Itana nothing much. Anyway, the equation. Okay.
Okay.
So here for the alternative approach, now then this is for the, okay, wait. This is, okay. In this alternative approach, now then direct equation was y is equals to beta naught plus beta 1 x1 කියලා කියන beta 1 x plus epsilon කියලා කියන එකනේ. So now with the alternative approach, for this alternative approach, we can calculate this alternative approach, that is beta naught is equals to y bar minus beta 1 hat x bar. That means earlier what we had was y is equals to beta naught plus beta 1 x. Let's assume we rewrite this for the means කියලා. එහෙනම් what will happen? We have y bar is equals to, again the beta naught will be constant, beta naught plus beta 1 x bar. Beta 1 x bar. Okay. Y bar is equals to beta naught plus beta 1 x bar. Here, what they have done, they have made the subject as beta naught. May beta naught take a subject take we can take this beta 1 x bar to the other side. Etakota, we have y bar minus beta 1 hat beta 1 hat x bar is equals to beta naught. That's what we have. Is it clear how we get this equation?
Okay.
මේ තියෙන බීටා නෝට්ට මේක සබ්ජෙක්ට් එක කරාම අර ජෙනරල් ඉක්වේෂන් එක ලියලා you have to get the mean values. Mean means you have to consider the mean values, averages. So after determine the beta naught and beta 1 values and the best fit line, the values taken for y is called as estimations, which is denoted by hat. Hat taking එක එනකොට අපි ඒකට කියනවා estimation එකක් කියලා. Beta naught is equals to the predicted value of y. Beta naught is equals to the predicted value of y when x is equals to 0. Beta 1 is the changes of y with the changes of x. Beta 1 කියලා කියන්නේ x change කරනකොට y ගේ වෙන changes ටික. ඔන්න ඕක තමයි beta 1 and beta naught කියලා අපි කියන්නේ. So the negative beta 1 will be get an inverse relationship, and for the positive beta 1 will be a positive relationship. That's what we have.
Miss, can we use any method?
Yes, we can use any method.
Okay.
තමයි එක්සෑම් ඩියුටි එක ඉන්නේ සුපර්විෂන් එක නිසා සර්ට ඩිප්ලෝමා එකේ උදේ ලෙසන් එක කරන්න වෙන්නේ නැහැ කියලා කිව්වා. සර් ඇහුවා සර් තමයි සුපර්විෂන් දාලා තියෙන්නේ. සර් ඇහුවා ඔයාට පුළුවන්ද කියලා උදේ හවසයි දෙකම කරන්න ලෙක්චර් එක කැන්සල් කරන්න නැතුව. එතකොට සර් ඔයාගේ සෙෂන් එකක් ඒ කියන්නේ ඊළඟ සතිය වගේ සෙෂන් එකක් සම්පූර්ණයෙන්ම අරගන්නම් කියලා කිව්වා උදේ හවසයි. ඔයාට පුළුවන්ද එහෙම කරන්න? පටසිරි. එතකොට ඔයා නැත්තේ ඔයා ඉන්නේ උදේද හවසද? හෙට තියෙන එකයිනේ. හෙට තියෙන උදේ විතරයිනේ. සර් දැන් ඉඳන් කියනවා එක්සෑම් මොනවාද ලෙක්චර් එක කැන්සල් කරනවට වඩා හොඳයි මේ කාගේ හරි එහෙම වුණොත් ලහිරුලා කාගෙන් හරි ගෙන් ඒගොල්ලෝ නැතුව ඇතිනේ. ඒගොල්ලෝ තින්නවද දන්නේ නැහැ ඔක්කොමලා. හ්ම්. එහෙමත් කෙස් එකක් තියනවා නේද? ඔයා මොනවද හෙට කරන්න ඉන්නේ? නෑ. ඔයා මේ හවස ලෙක්චර් එකේ මොනවද කරන්න ඉන්නේ? හවස කරානේ. නෑ උදේ සෙෂන් එකක් තියෙනවා නම් මට හරි නිකන් උදේ පැය 4 කැන්සල් කරන්න නැතුව ඕනනම් මම මොන හරි කරන්න කියලා මම බැලුවේ. Okay, so here then beta note the predicted value of y when x is equals to 0. හරිනේ ඉතින් අපි intercept එක කියලා කිව්වහම නේ intercept means that is අපේ normal Cartesian plane එකක වුණත් intercept means when x is equals to 0 the y value when x is equals to 0 no. So that's what here also we have defined beta naught is the predicted value of y when x is equals to 0, beta 1 is the changes of y with the changes of x. That's what here we have. Make a beta 1 කියලා කියන්නේ the slope. The slope is when we have the changes of x, what would be the change of y කියලා කියන එක. Negative beta 1 inverse relationship. Negative beta 1 means there we have a negative inverse relationship in between x and y. Positive beta 1 means when the x value increases, y values also increases. That means the positive relationship. That's what we have. So then, these are the intercepts and these ones. That part we already did. Okay. So now the total variation. So for the total variation is මේ වගේ questions නැද්ද?
No, is there a question separately as an exercise?
Okay. So for the නෑ මෙහෙම rather than doing whole the theory part at once මේ regression වලින් එක question එකක් කරලා then the alternative regression වලින් එක question එකක් කරලා ගියා නම් it would be ideal, but we have only 4 slides now. I'll complete the rest of the slides, then we'll do some questions as well. So for the total variation, that is the total variation, sampurna, the total variation. So for the total variation, that is variation is measured by taking the mean as the base, mean එක base එක කරගෙන, then the total variation is equals to, explained by the regression plus unexplained by the regression. Total variation means regression එකෙන් explain කරන ප්‍රමාණය plus regression එකෙන් explain කරන්නේ නැති ප්‍රමාණය. So then the real variation means the actual value minus the mean value, yi minus y bar. Yi is the actual raw data, y bar is the mean value. So the difference in between these two tamai, we call them as real variation. So the variance explained by the regression line is variance explained now, it is yi hat minus y bar. The variance unexplained by the regression is yi, that is the actual value, minus yi hat. This is the explained variance. This is the unexplained variance. This is the explained variance. This is the unexplained variance. So what we want is, we want sigma yi minus y bar hat. That means the real variation. We want the real variation squared, summation of the squared of real variation. That is equals to sigma what? That is equals to sigma yi hat minus y bar plus sigma yi minus yi hat get squared. Here the squared also there. ඒ කියන්නේ දැන් මෙයා කියලා කියන්නේ මේ දෙන්නගේ addition එකනේ. So then මෙයා කියලා කියන්නේ මේ දෙන්නගේ addition එකනේ. You can see once you add all these two, again you will receive the same one. ඒක දැක්කද ඔයා? yi minus y bar is the total real variance. If we add these two terms together, hari ඔන්න බලන්න, yi hat minus y bar, if I add the unexplained regression, that is yi minus yi hat, you can see these two terms got cancelled. So then the remaining part is again yi minus y bar. See, that's what we had in left side. The same thing. එහෙනම් මෙයාගේ ස්ක්වයර්ඩ් එක is equals to මේ දෙන්නගේ ස්ක්වයර්ඩ්ස් වල එකතුවට. Is it clear what I did?
Yeah.
Okay. Habay for this lesson, you just I'll upload the recording today itself somehow. Then you just go through with the recording as well. I mean numbers it's a little bit hard, I think. So
Yeah.
here yi minus yi ge bar is equals to මෙතන තියෙන්නේ තරකම තමයි අර දෙන්නගේ addition එක is equals කියලා කියනවා for the total regression. Regression is equals to explained regressions plus unexplained regression. That's what we have. Then for these regressions, we are calculating SST, SSE, SSR. The standard squared T refers to E is error, R is regression, T is to SST. SST is SST. Give me 1 minute. SST means total sum of squares. Sorry, total sum of squares. SSE means total sum of errors. SSE nang E stands for errors. SST means total sum of errors. Okay. So total sum of errors. Okay. So sum of SST means sum of totals. SSE means sum of errors. SSR means sum of regressions. Okay, sum of regression. So SST is equals to SSR plus SSE. That's what we have here. Okay, so then for the coefficient of determination, quantifies the proportion of the variance of one variable by the other. It numerically present how far the change of one variable is explained by the other variable. That is what we call the, can numerically present how far the change of one variable is explained by the other variable. So coefficient of determination is presented by R squared. Then මතක තියාගන්න, we have coefficient of correlation. We have coefficient of covariance. We have coefficient of, oh, oh, oh. Uh, hmm. අපේ ලැබ් එක මේනකාට අරින්න කියන්න බැයිද මේනකා බෑ කියලාද කියන්නේ? අනික නිකන් ලැබ් එක අරින්න විතරයි නේද තියෙන්නේ? මම නිකන් දමයන්ති මැඩම් ඔයා නිකන් ඇහුවද මේනකාගෙන් නැත්නම් අනේ නැත්නම් මම හ්ම් හැබැයි ඉතින් ඕකේ එකපාරක් අරින්න විතරයි නේද තියෙන්නේ ඊට පස්සේ එයාට හා 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 උෂානි එනවද ඒ කියන්නේ සාමාන්‍යනුත් කොහොමත් හා හා බලන්නකෝ මේ මට මොකක් හරි අවුලක් තියෙනවා නම් කියන්නකෝ ෂේප් එකේ මේනකා එන නිසා ඕනනම් අරින්න කියලා කියන්න අපිට ඉතින් කොහොමත් මේ එන නිසා මම බැලුවේ ඉතින් ෆිසිකල් කරා නම් හරි කියලා ඕක බලන්නකෝ එන ඒක තමයිනේ ඒක තමයි ඒක තමයි මට හිතනවා ෆිසිකල් තිබ්බනම් හරි කියලා බලන්නකෝ අපි ගිය සති කරෙත් නැති නිසා මේ මට නිකන් බල්ලා කියන්නකෝ අරින්න මේ මේනකාට කියන්න ඕන නම් මං කියන්නම් හොඳේ ඔයා මට නිකන් කියන්න හරි 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 මං කියන්න මට ආවහම මෙසේජ් එකක් දාන්නකෝ ඒතර මං කියන්න හරි So here for the coefficient of determination means r squared and you should know the coefficient of correlation eka r and also you should know coefficient of covariance as well. ඔය තුන පටලව ගන්න බෑ. With the equations you should know all these three. මෙතන එන්නේ coefficient of determinations. Coefficient of determination is r squared. හරිද? Coefficient of determination comes as r squared. So the coefficient of determination is the square of the correlation coefficient. මේක ඇවිල්ලා coefficient of determination කියලා කියන්නේ r squared කියලා කියන්නේ r ගේ squared එක r means the coefficient of correlation. එහෙනම් coefficient of correlation එකේ squared value එක තමයි we mentioned it as coefficient of determination. හරි? Is it clear?
Yeah.
Okay, then coefficient of determination එහෙනම් SSR divided by SST. So SSR we calculate it as yi hat minus y bage squared. Summation එක should divided by SST is yi minus y bage squared. So these ones measures how the variation of y is explained by x. What is the proportion between the variation explained by the regression with respect to the total variation? Simply the square of the coefficient of correlation is there, and also when it comes to rank r squared now for the correlation we had negative values as well. By for the coefficient of determinations that is r squared. R squared means we have already squared that value. Here we only get positive answers. So that means it's lie in between 0 to 1. Ekai metana kiyan. When r squared is 1, that is variation is really high. R squared is equals to 0 now, variation is really low. Hari, is it clear?
Okay.
Okay. Then the last part, standard error of estimation. So the standard error best fit line shows the estimates for y. And points are closer to the best fit line. That is estimations are really good. Therefore, the estimations are considered as more reliable and the standard error measures is equals to the dispersion of observed values about the regression line. So the standard error means how we gonna calculate the standard error? That is total sum of errors should divided by n minus 2, that is the number of elements minus 2. Once we have this value, we should take the square root of that value. Standard error. Or standard variance එක වගේම තමයි. For the standard variance නම් අපි variance එක calculate කළා, then we took the square root නේ. Now here for the standard error now, first what we have to do, we have to calculate the total sum of errors. Once we have the sum of squared errors, again total sum of sum of squared errors. SSE means sum of squared errors. SST means total sum of, again, sum of squared totals. Sum of squared totals. එතකොට අතන SSR means sum of squared regressions, SSR. එහෙම තමයි terms තුන හැදෙන්නේ. So here for the SSE divided by n minus 2 into square root, again, completely we have to take the square root. That's how it is. Hari?
Okay.
That is the standard error. Okay. Do you have an exercise on this as well?
Yeah,
Okay. Did you send it to me?
I'll send me.
Okay. Okay. Sketch the data on a scatter plot, develop the best fit line, do some predictions. Can you first sketch on this and draw a best fit line?
Okay.
අම්මේ මට ඔය ඉන්න ගමන් කවනවා හරි මම කනවා.
Miss,
Yes, did you do?
Miss, how to get the best fit line?
Best fit. Okay. Best fit, we had two, not two, three methods now. Hmm. One method is with the free hand. Free hand one එක නම් නිකම් බලලා um, you can draw that line. For the second method, what we can use is that is for the likelihood method. So for that likelihood method, what do we have to do? We have to draw this fitted line uh, where we can have the minimum error. හරිද? ඒ කියන්නේ minimum error එක calculate වෙන පරිදි minimum error එක තියෙන විදිහට තමයි we should draw the fitted line, best fit line. එතකොට okay, give me 1 minute, I'll wash my hands and come quickly.
Okay.
So here, sketch the area on a scatter plot. That one you can, x-axis you can take it as 5, 4 මේ තියෙන values, and for the y-axis වලට වෙනමම පුළුවන්. Since we have only few data, can't we draw it with the freehand? මම හිතන්නේ මේකට නම් they are expecting that method. Draw best fit line. Sketch the data on a scatter plot and draw the best fit line. In forecasting model based on, yes, that's how it should be. Let me share the whole screen first. And regression. So then these are the methods: a free line, two middle points, a line using two middle points. Line using two middle points. Okay, so once you draw the scatter plot, so you can find out that approximate line, no, y is equals to mx plus c. Actually, that is y is equals to a plus bx equation. Once you found out that equation, you can draw that with the minimum error. So that
So
the
we
E line,
just draw the line.
yes, just draw the line. Yes, so what should be there? The E value should be equals to 0. That means actually the what we call the error should be minimalized. Error should be minimal. A line using first and the least point, or else least square method. Either out of these four methods, you can use one method and draw it. ඒගොල්ලෝ අඳින steps නම් කියලා නෑ. Yeah, free draw hand nang this would be this, and for this one nang see. So you have to write deviations, and first the deviation shows the errors of the model. Therefore, to get the best fit line, the errors should be minimalized. Once you draw this line, you can calculate the respective errors. මෙන්න මේ විදිහට මැදින් කැපෙන විදිහට තමයි you should draw this. අන්න හරි. Yes. හැබැයි මේක තව ටිකක් angle කරන්න තිබ්බා because so you can see one ඒ කියන්නේ දැන් all these three are most those three dots are in the line itself නේ කොහොම කරත් but the other two one is a little bit it has a little bit higher error. The error amount is higher what is available in the top. හැබැයි යට තියෙන එකේ the error is a little bit smaller. ඒක නිසා තව ටිකක් උඩ පැත්තට angle කරා නම් මේ දෙන positive or negative වෙලා those two errors got cancelled. තේරෙනවද මම කියන එක? දැන් ඔය ඇඳපු එක මෙහෙම නැතුව if you can draw it like this අර මේක අරගෙන මෙන්න මෙහෙම තව ටිකක් අර මෙහෙම යන විදිහට වගේ ඇඳනම් දෙපැත්තේ තියෙන distances දෙක equal වෙන විදිහට points දෙකට then it is ideal. So because of that the plus or minus වෙලා the error got cancelled.
Okay.
Okay, can you do the rest of the questions at home and send back to me? We'll do
Okay.
so now the lesson 10 also completed no?
Yeah.
I can do a class on Monday evening as well. If so, we'll do the lesson 11 and 12 also Monday itself. So
Okay.
that is, we have only 14 lessons, right? So
Yeah.
that we can complete all the lessons within other 2 days, 2 or maximum 3 days, we can complete so that
Yeah.
we can quickly move to the questions and the past papers. The entire month of April, we can do the questions and move past papers. Okay.
Yeah. Okay, miss.
Okay, let's do like that.
Okay.
Thank you.
Okay,
Then
miss.
see
Okay,
you.
thank you, miss.
Bye.
Okay, bye.
Bye.